Hello, welcome to this video. In this video, we'll be looking at curve sketching. So this is curve sketching part one. So we'll not be looking at a particular type of curves. We'll only be looking at a few simple curves. The steps that we shall use to sketch these curves are these three simple steps. Step one, we'll locate the x and y intercepts of the curves. Simply by substituting the equation of the curve y is 0 to get the x-intercepts, and then x0 to get the y-intercepts. Then we'll find the stationary point of the curve. We shall use the procedures that we saw in the previous video to do this, and then we shall investigate rather the nature of the curve as x tends to positive infinity and negative infinity. We'll see how to do this. Just look at the examples that we have. So first, we've been asked to sketch the curve y is equal to 4x cubed minus 3x to the power 4. Now first we said we'll find the x and y intercepts. We could start with n x is 0, and x is 0. Y will simply be 4 times 0 cubed minus 3 times 0 to the power 4, which is 0. So we have the point 0, 0. Okay, how about when y is 0? Now when y is 0, we'll have 4x cubed minus 3x to the power 4 being 0. This is the same as x cubed times 4 minus 3x being 0. And so here we have two solutions that either x is 0 or x is 4 out of 3. And so we have the 2 points, 0, 0, which we already got, and the point 4 out of 3, 0. So we have those two x-intercepts. Okay, so find the intercepts. Step 2 is to find the turning point. How to find the turning points? We differentiate equation of the curve. When you differentiate, we'll have 12x squared minus 12x cubed. Now you equate this to 0 to find the turning points. So we're going to equate that to 0. We'll have 12x squared times 1 minus x equal to 0. And so the x values at the turning points are 0 and 1. Now we have to investigate their nature, yeah? So we'll go with left, x being 0, immediate right of that, and then x being 1 to the immediate right of that. So these are the values of x, and now we want to investigate the sign of dy dx at these points. Now dy dx is that expression is right there, so don't get confused. We know that here it's going to be 0 and that's going to be 0. Now realize that for 0 to the immediate left of 0, this is going to be positive. And to the immediate right of 0, this is still going to be positive. And hence we have a point of inflation right there. At the point when x is 0, we know that y is 0. So this will be at the point 0, 0. And then for when x is 1, to the immediate left of x being 1, we'll have a positive here, and to the immediate right of x being 1, we'll have a negative. So at this point, we have a maximum. Now when x is 1, we substitute for x in this equation, realize that y will be 1. So this is at the point 1, 1. Now as x tends to positive infinity, what does y tend to? Just by looking at the equation of the curve, you can see that as x grows increasingly large, this term will be much bigger than this one because of the power. Therefore, y will tend to negative infinity. Also, as x tends to negative infinity, so as x grows increasingly large but negative, y will still tend to negative infinity because this will be a big positive number and you'll be subtracting it from another big from a negative number already. So it will be largely negative. So now that we have all we need, we can sketch our curve. So that's the y-axis, and the x-axis. We know that I'll just change the color of the ink. You know that at the point 0, 0 and at the point 4 out of 3, 0, we have intercepts. We have point of inflation at 0, 0, and your curve something like that. At the 0.11, we have a maximum. And yeah, the 0.430, we have a minimum. Of course, supposed to be a smooth curve. So I'll just redo that. And so that point there, your maximum, that's the point 1, 1, 1. This is 4 out of 3, 4 out of 3, 0. Then you can go ahead to label the curve. Y is equal to 4x cubed minus 3x, 3x to the power 4. That's how we sketch curves. Okay, let's do another example. We have the curve y is equal to x to the power 4 minus 10x squared plus 9. First thing we do is find the intercepts. So when y is 0, we'll have that x to the power 4 minus 10x squared plus 9 is equal to 0. So what do we have there? We have that when this is the same as x squared minus 1 times x squared minus 9 being equal to 0. So we have x being plus or minus 1 and x being plus or minus 3. So we have 4 points there, negative 3, 0, negative 1, 0, 1, 0, and 3, 0. So 4 intercepts there. Then when x is 0, we have our y simply being 9. So we have 1 y intercept over there. Turning points, this is 4x cubed minus 20x, which is 4x times x squared minus 5. So if you equated this to 0, you'd have your x being 0 and your x being plus or minus root 5 as x values that cause turning points. So if we went ahead to draw our table, left negative 5, right, left 0, right, and then left root 5, right. So looking at the immediate right of these x values to see whether we have, the sign of dy dx being positive or negative. And if you do this carefully, you realize that you have something like this. And so we have a minimum at that point, have a maximum at that point, and a minimum at that point. Now you want to go ahead to find, the actual values of the y values at those points. And I already know that when x is 0, y is 9. We know this from here. What when x is negative root 5? So when x is negative root 5, y would be, this would be 25 minus 25 is 50 plus 9, which is negative 16. And that's the same for when x is positive root 5. And so you have that y is negative 16 when x is plus or minus root 5. So that's where the minimum points are. And so what do we do? As x tends to positive infinity, what does y tend to? Realize that we have x being a huge number, x to the power 4 is going to be a really huge number, minus 10x squared would be really huge, but not as huge. And so y would also tend to positive infinity. And as x tends to negative infinity, you're raising a negative number, but to the power 4, which is an even power. And so y would still tend to positive infinity. And so we draw our axes, the x and y. We have intercepts at 0, 9, negative 1, 0, negative 3, 0, 1, 0, and 3, 0. Positive root 5. Root 5 is, just above 1, just above root 4, which is 2, rather. And so looking at a point that's somewhere right here, and similarly, point that's, somewhere right there. for the minimums. And so our curve would progress as shown. Of course, it's got to be smooth. And then you can label the points, and then you could also label the curve. And so that's basically how we carry out curve sketching.